Hello and welcome back. In this video, we shall talk about working with numeric data type. So I'm back to the tab numeric, working with numeric data type. In the previous one, we just gave an overview of how to view the different data types of any table using the keyword called pragma. So now let's look at how to work with numeric data type. So one of the column that has some numeric values is the tracks table. So let's just view the information of the tracks table using the pragma table underscore info tracks highlight and run. So on the tracks table, we have these columns called the track ID, which is an integer, name, which is stored as nvirtual 200, album, which is an integer, media type integer, genre ID integer, composer nvirtual 220, milliseconds integer, bytes integer, unit price numeric 10 comma 20 sorry 10 comma 2 rather. So this is what it is. We would learn how to work with numeric data from this table. So just to go through this particular comment, said we see that when we look at the table, we see that it contains six integer columns: the track ID, the album ID, the media ID, genre ID, milliseconds, and byte columns. Right now, let's take a closer look at what these columns contain. Note, we limit our results to 10 rows. So let's see what the columns contain. So we're selecting each of those columns that we see that has a data type integer. I want to write a query to just display the records under those columns: track ID, album ID, media type ID, genre ID, milliseconds, and bytes. From tracks, so limit 10 means I want to see just the first 10 items. Highlight these guys and run the query. So when you run the query, you would see that it has given you an output, a display of all first 10 records stored under this table and for this particular column selected. Okay, so let's continue. As expected, all these columns contain integers. However, most of them are column IDs. This means that we could generate them ourselves using serial integer types if we had to rebuild the database. Now, a good way to analyze the properties of a given numeric data column is to use summary statistics. So whenever I want to analyze the different what is it called now, different feature or attributes of a numeric column, just go ahead and use summary statistics. So let's see how to do that with these data sets that we're working with. All right. So to achieve that, to achieve some summary statistics, we would begin with the bytes and the millisecond seconds column. So here is a syntax. Now what am I trying to do here? I want to, this query looks so complex, right? I'll break it down bit by bit and then try to help you understand what's going on. So I intend to show the maximum bytes and the minimum bytes, okay? And not just that, I also want to calculate the average bytes, right? And the maximum milliseconds, the minimum milliseconds, and the average milliseconds. So this is just calculating summary statistics, okay? And these values are all gotten from the tracks record and from the media types table, the tracks table and the media types table. So when I run this query, you will see the output, and then we shall run the query again from beginning and show you what this means. So this is the output of the query. Okay. So what we've just done here is we've calculated the maximum bytes for each media type, the minimum bytes for each media type, the mean of the bytes for each media type, and then the milliseconds, maximum milliseconds for each media type, minimum milliseconds for each media type, and so on and so forth. So with this is just like a summary statistics of the various media types that make up the Chinook database. So you can come here and say, okay, let's see the media type that has the maximum bytes for uh, every single media or tracks produced is actually the protected MPEG -4 video file. Can you see how great, how the how large the byte is? So this is the largest byte. Has the highest maximum for all the media types that have been produced. Okay, want to see the media type that has the longest track from all maximum, and that media type will also be this guy, the fourth one, the protected mpeg-4 video file. You can see it has the highest milliseconds, which is about 5,286,953 milliseconds. Okay, followed by mpg audio file, which is about 1,612,329. Okay, so with this, we've gotten a summary statistics, and we can just explore each of these and see make some sense out of it. Okay, so now let's get back to the query. So what is this query doing? How do we interpret this query? How are you able to write this query from scratch without seeing this from your head, without bothering yourself about, oh, how it's going to come out? So first of all, the information displayed here, they are they are gotten from two tables: tracks and media types tables. Although I know we are yet to discuss joins, we shall discuss joins in uh, next next week. Yes, we can talk about joins next week. So for now, I would just appreciate if you you don't bother yourself so much about how this is working. Just try to memorize it. But if you want to know the various joins and how to use the join statement, you can do your personal research. All right. But before then, before we talk about it officially in the class, I will just use it. So see it as one of those syntax that you want to use to get information from more than one table. Okay, let's display the tracks table. So I want to break down this query. I'll just break it down for you to be able to understand it. I would write a query to display the tracks table, or the columns from the tracks table, from tracks. Okay, let's run this query. All right, so when you run this query, what you see is the tracks, all the tracks that have been produced. And now from the tracks, you see we have a column called media type ID. So if I want to perform this query, if I want to execute this query without joining two tables, I can still do that with just the tracks table. So let's do that right away. We want to get the I want to display the track ID, right? I want to display so I'm going to modify this code I wrote. I want to display the track ID, I mean the media type, because our focus is on media type. The media type ID, and I want to calculate what are the things that were calculated, the maximum bytes. So there is a column called bytes, right? So I'm calculating the maximum max of bytes. Okay, the maximum bytes. I'm also calculating the minimum bytes, the minimum of the bytes of all the media types stored. And then I'm also interested to calculate the average bytes, right? I want to calculate the average bytes. So where is my query? The average bytes, AVG of bytes. What else do you want to calculate? Want to also calculate uh, the maximum milliseconds, comma, max milliseconds, maximum milliseconds. I think so. Here is milliseconds. We have a column called milliseconds. Then we want to calculate the minimum milliseconds, mean milliseconds. We also want to calculate the average milliseconds, the average milliseconds. All right. So since we're performing aggregation, okay, let me show you something. When I run this query without adding the group by function or the group by clause, we would see just one line result. We can see the maximum bytes, minimum bytes, average bytes, maximum milliseconds, minimum milliseconds, and average milliseconds. This is for the entire record stored in the table called tracks. That's calculated the maximum bytes for all the tracks, irrespective of the media type. That's calculated the minimum bytes for all the tracks, irrespective of the media type. It's calculated the average, and so on and so forth. But if we want to see these values across each media type, for each media type, you want to see for media type ID, the media type ID one, you want to see some a value for the um for for each of this quantity, the maximum, minimum, byte, average, and the rest. And for media type 2, you see the same values for media type 2, media type 3, 4, 5, and so on and so forth. So the line of query you need to write add to this is just a group by. So you can then group this query by the media type. So I'm grouped by media type because I want to see the all the statistic for the various media types that are contained in the computer. So once you do that, highlight it and run this. And once you run, you would see the distribution given below. So you can see now that we've been able to calculate the maximum, minimum, average, and for bytes and milliseconds for each media type. Okay, so I was able to do this successfully without joining two tables. Okay, let me run this query again. So you take note of the difference. This is the query I just typed and I displayed. If you run that query that I selected, this is what we see. So we're seeing almost the same values, right? Let's check again to ensure that we have the same values. Okay, yes, we are seeing the same values, right? Just that they are not ordered in that manner. This is ordered in according to the number of the course ID, but in your own attempt, it has a different ordering, right? It has a different ordering. When run this, so they are the same values but different ordering. All right, so let's then go ahead and see how to. Okay, now what's the other difference? You see that under name, this is showing the names of the media types. But if you run my query does not show the name of the media types. It only showed media types ID. So how do I now display the names of these media types instead of displaying their ID? That is what will now take us to allowing us to join. Since when you check out the media type, select asterisk from media type. So when you check out the media types table, you'll notice that there are there's a column called name, which is associated with the nature or the media type ID. So this name. So wherever we see ID1, let's substitute it with MPEG audio file. Whenever we see ID2, let's substitute it protected AAC audio file. Lecture 3, let's replace it with protected MPEG 4 video file. So that is how to go about this. And to do that, to achieve that, to add these names to my query that didn't show names, mine was showing numbers, right? Just numbers. So to add it, I'm going to join this. So I'm joining from before the group by, just after the from. So select this from tracks. I join the media type. I'll join the media types on the media types on. So when you check it, we have the media type ID on both tables. So we are joining them on the media type column equal to media type column. So but right now, since we're saying media type equal to media type, doesn't make so much sense. So we have to specify what column is the first media type gotten from. So the first media type is gotten from the tracks table, tracks dot media type, right? And I would get the second column from the media types table. Type in media types dot media type. So that will give us the answer. So that will help us display the the names of the media types as against the what is it called, the code. So let's try this out. Highlight it and run. When you run this, you would see, okay, we have an error, ambiguous name. Oh, so it's saying that when you see this error, this message, what SQL is saying is that the SQL finish, I mean the query executed with finish with errors. Our result is ambiguous name column media type. So it's asking, because we have media type in both tables, what is this media type? Where, because we have media types on this column and it appears in both columns. So you can just say let this media type come from the tracks, right? Let it come from the tracks dot media type. If you do that, we can then run this query to see. I have to highlight all, and I'll run this query to see if the output come. So there I see error because we said there is no such name as media types dot media type. Oh, I think so that's a mistake from my end. Let me delete one of these media type. So once we delete one media type, we'll run it again, and hopefully we would get a result that makes sense. Oh, we're still having issues. Oh, okay, so I think what's remaining now is for us to specify where each of this column is gotten from. So bytes is from the tracks table. So I call tracks dot bytes, and this byte is also from the tracks table. Let me just copy all of this and replace it with the bytes. Replace it here. Replace it here. For milliseconds, it's also from tracks table. Tracks dot milliseconds. I would also paste it everywhere. Okay, hopefully our query will run now. Okay, one more. What's media types? Ambiguous media type. Is there any media type that we've not actually captured? Is there any other media types? Oh, here we are grouping by tracks dot media types. Please bear with me. Tracks dot media types. So right now, this query should run hopefully. Okay, so amazing. So as you can see, we've been able to run the query, but yet it's still media type ID that is showing. So for us to display the name, we have to now add the name to the list. So let's say I want the media type to show as well as the name from the media types table. So media types dot name. So I want the name to show from the media types table. So if I should do this, you would see the track ID against the media type name. So can you see? So it has been arranged in such a way that we have one, which is the MPEG audio file, and it gives you all the information. Then two, protected AC audio file. Three, so you can simply display results from two tables by just joining those results. And this same thing that we saw here is something that this line of query does. Okay, don't like I said again, don't don't be intimidated with the number of uh, comments and functions that make up the query. That was the reason why I did it again from scratch. All right, so I would like you to go ahead and explore the other data types. I mean, the other queries that we have here, under the numeric data type. Learn them and ask questions if you have any. We shall discuss it together in the classroom. So, bye bye.